Hello friends, welcome to another episode of Stars Knowledge. Today we are going on a scientific journey inside an electric kettle. In this video, we'll examine the components of the electric kettle, understand how these parts work together, have a general overview and comparison with other models, discuss potential dangers, and finally conclude. If you find this topic interesting, please hit the like button and stay with us until the end of the video. At the first, what is the electric kettle? The electric kettle is one of the most commonly used appliances in daily life, which uses electrical energy to quickly heat water and bring it to a boil. And now, what are their components? Body and handle. The body is made of heat-resistant plastic like polypropylene, which protects and holds the internal components. The handle is also made of thermal insulating materials to prevent burns when moving or pouring water. The lid is located on top of the kettle. Now the most important part is heating element. At the bottom of the kettle, there is a heating element responsible for generating heat. This element is usually made of nichrome alloy, 80% nickel and 20% carbon, or stainless steel. Due to its high electrical resistance, when electricity passes through it, it heats up and produces heat. The element is designed as a flat or spiral shape in a thermal disk to evenly transfer heat to the water, and here we have a flat shape. The power of the element typically ranges from 1000 to 3000 watts. For added safety, the element is protected with thermal and electrical insulators like ceramic or mica. Now, white plastic parts at the here. These parts, usually made of polycarbonate or polypropylene, hold the heating element and prevent water from entering the electrical section. Now, power base and thermal disk. The kettle's base, which is usually detachable from the body, includes electrical terminals that connect the element to the power source. The circular design and soles in the base help dissipate heat and prevent overheating. Now, internal wiring. Under the kettle, there are two wires, blue and brown, which are here. Which are part of the electrical circuit. The blue wire is usually natural and the brown is live. These wires carry electricity to the heating element. Now power cord. The cord consists of a plastic cell, usually PVC, and internal copper wires that deliver electrical current from the outlet to the kettle. The cord must comply with safety standards. We don't have a thermostat here, but I want to talk about thermostat for you. The thermostat is a thermal sensor used in more advanced models to control temperature and automatically shut off. Its absence means the user must manually turn off the kettle. Now, how the electric kettle works? The operation of the electric kettle is based on physical principles such as Joule's law, heat transfer, and the simple electrical circuit. Now we will examine these step by step for you. At the first, connecting to power. When the kettle's plug is connected to a 220 volt outlet, alternating current, AC, enters the internal circuit. This current is directed to the heating element via the power wires. The second part is closing the circuit with a switch. In most models, the kettle has an on-off switch. Pressing this switch closes the electrical circuit, allowing current to flow through the element, which we don't have here, and it do it automatically. Heat generation by the element. The heating element or thermal disk at the bottom of the kettle is typically made of nichrome alloy, which has high electrical resistance, as I said before. According to Joule's laws, it means that as electrical current passes through the resistance, electrical energy is converted into heat. This heat is generated in the element and quickly transferred to the surroundings. Heat transfer to the water is the next step. The metal plate under the kettle transfers heat directly to the bottom of the water reservoir due to the high thermal conductivity of the metal. This process occurs through thermal conduction and the water temperature being raised. The next step is what? Reaching the boiling point. When scientific thermal energy is transferred, the water temperature reaches 100 degrees Celsius, the boiling point at standard atmospheric pressure. At this point, steam is clearly visible, and the sound of boiling water is heard. The last step is device shutdown. In kettles equipped with a thermostat or thermal fuse, when the water or body temperature reaches a certain level, the device automatically shuts off to prevent the element from burning out and damaging the device. Without thermostat, manual shutdown. However, in kettles without thermostat, like the one here, the device does not shut off automatically. Therefore, the user must manually turn off the kettle upon hearing the boiling sound or seeing steam. The absence of a thermostat poses risks that we will discuss later. Now, we will have a scientific summary of operation. Operation of the electric kettle. Here. Operation of the electric kettle is an excellent example of converting electrical energy into thermal energy and transferring it to a fluid, water. In this simple yet precise process, at the first electrical current, then we have high resistance element, then heat production, Joule effect, then we have heat transfer to water, conduction, then we have reaching boiling point, and the last part we have automatic or manual of power. This basic mechanics is used in many similar heating devices. Now, if we have how the temperature control system works in this kettle. If there is no thermostat, how is the heat controlled? At the first possibility, manual on-off. In older or cheaper models, the user must manually turn off the device. If forgotten, the element may burn out or even cause a fire. Second possibility, thermal fuse, a type of fuse that permanently cuts off at high temperature, for example 150 to 200 degrees. Unlike a thermostat, it is single use and must be replaced after activation. The third possibility, mechanical mechanism in the lid. In some models, steam pressure activates a latch here. In the light, cutting off the power. The system is not very precise. Now, dangers of not having a thermostat. The absence of a thermostat can be dangerous. At the first, fire hazard. If the water completely evaporates, the element remains hot and may cause the body to melt or even start a fire. Second, burns. Hot steam and the body can cause serious burns. Third, damage to the device. Overheating can disable internal components. And need for constant supervision. The user must always be present. Now, we came to comparison with other electrical kettles. Electric kettles are generally divided into two main types. Those with an exposed heating element, like this model, and those with a concrete heating element. We have a picture here, okay? Electric kettles with exposed and concrete elements differ based on the placement and design of the heating element that produce heat. Let's compare these two models. Exposed element. The heating element is visible as a wire or metal plate inside the kettle and is directly immersed in water, like kettle we have here, as you can see. How it works? When powered, the element produces heat which is quickly transferred to the water due to direct contact. The advantage of this model: faster heating due to direct contact and generally lower manufacturing cost and price. Disadvantage: harder to clean as scale and deposits easily accumulate around the element. May rust over time. less safe if water is low, as the element may burn out without water, like as you can see here. Now we came to concrete element. Here, the element is hidden within a metal or stainless steel plate under the kettle's floor, not visible in the water. How it works? Heat is transferred to the water through the floor plate. This design allows for more even heating. Advantage of this model are easier to clean since no parts is in the water to calculate deposits, longer lifespan due to better element protection, safer with modern sensors that prevent operation without water, and disadvantage of this model, heating may be slightly slower than with an exposed element, higher manufacturing cost and price. The main difference between these two models are, at the first, water contact. Exposed elements are in direct contact with water, while concrete elements are not. Design. Concrete models are more modern and stylish, whereas exposed elements are more common in older models. More modern kettles have advanced sensors like automatic shut-off or over-voltage protection, which our models don't have. In terms of design, newer kettles are lighter and more aesthetically pleasing. But older models like this one have their own durability and simplicity. For conclusion, our electrical kettle is a simple model with main components including a plastic body, insulated handle, power cord, nichrome, heating element, plastic holders, and a base with thermal design. This device uses the electrical resistance of the heating element to convert electrical energy into heat and bring water to a boil. I hope you enjoyed this scientific review. If you found this video helpful, don't forget to like, share it with your friends, and be sure to leave your comments. Until the next video from StarKid Electro Lab, goodbye!